Hi, in this video, we're going to talk about four things mainly. We're going to talk about the definition of a radian. What is a radian? And then we're going to talk about how we can find arc length. And to convert, if I give you the radians, how can you convert it to degrees? And if I give you radian, how to convert it to if I give you degrees, how to convert it to radian. So four things. So the first thing, the definition of radian. So before I read out this definition to you, let me just explain it using this diagram. What's a radian? So let's say this is a circle with center O, and I'm going to mark the radius of the circle as OA. Let's say that OA is 3 centimeters. Randomly, let's just say that this is a circle with center O and radius 3 centimeters. So if I measure the length of this radius 3 centimeters from A, if I decide to measure the same radius till here, let's say this is till here is 3 centimeters. If I get this arc as 3 centimeters, measure out this arc as also 3 centimeters, and I'm going to join this, then I'm going to call this point B. So arc AB and the radius OA are both equal. Then the angle that is made here with the central angle with the center, I'm going to denote it by the letter theta, Greek letter theta. This is called 1 radian. 1 radian here, right there. Okay, so as long as the radius and the arc length are equal, the angle that comes inside there is called 1 radian. So now if you try to read the definition, when the length of an arc of a circle, we're talking about the length of the arc of the circle, when it's equal to the radius of the circle, which is an example that I showed you in this diagram. The radius is 3, the length of the arc AB is also 3. When that happens, the angle subtended by that arc equals to 1 radian. Now, in degree measures, radian will be approximately around 57 degrees something, 57 point something degrees. So here's a formula for theta, or central angle, is arc length divided by the radius. Now the arc length, or arc length divided by the radius. Now the arc length is denoted by the letter S and R, small letter r for radius, like that. So the formula is theta is equal to S over R. Now from this formula for the central angle theta, which is S over R, from this main formula, we can also get the formula for arc length. How can we find the arc length S? Okay, so here the denominator for theta here is 1, and to solve for S, all we have to do is cross multiply. 1 times S, which is S, is equal to theta times R. Theta times R. So this is our second formula. S is equal to, or arc length is equal to, the central angle times the radius. So based on this, I'm going to quickly do two problems. Given the radius is 7 centimeter, so I'm going to write it here, radius is 7 centimeter, and the arc length, we know the letter S, is 2 pi over 3. What is the measure of the central angle? We know the formula for theta is S over R. So instead of S, we have 2 pi over 3. Okay, instead of S, I substituted 2 pi over 3 divided by, we need to divide it by the radius, which is 7. So the denominator for 7 is 1. So 2 pi over 3 times 1 over 7. We know that division is multiply and flip the fraction that comes here. Division is multiplying by flipping the fraction that comes after it. So our answer is 2 pi over 7 times 3 is 21. It's not possible to reduce this fraction further. So we can say that the measure of the central angle theta is 2 pi over 21. Okay, that's in radians. That's the answer. Next one. The radius of a circle is 5. So I'm going to put r is equal to 5. And the measure of the central angle theta is given to be pi over 4. What is the length of the arc? So they're asking you to find S. S is the length of the arc. S is theta times r. This is the formula we have to follow for S. So theta, the central angle, is given to be pi over 4 times the radius is 5. So the answer is going to be S is 5 times pi is just 5 pi divided by 4. We can just leave it like that. It's not possible to simplify this fraction further, so we're going to leave it like that. Now, our next topic is to convert to degrees. So let's do that. Now here the angle is given in terms of radians. That's why we know that because there's a pi in the question. Now to convert to degrees, what are we supposed to do? So I take pi over 6 and I multiply it by 180 divided by pi. So to convert to degrees, we have to multiply whatever angle that is given to us by 180 degrees divided by pi. 180 degrees divided by pi. Now what happens here is that the pi and pi are going to cancel and we get 180 divided by 6. The answer is 30 degrees. So we just converted pi over 6 is equivalent to 30 degrees. Okay. Here's a shortcut. Here's a shortcut. You just can change the pi to 180 degrees divided by 6 because we know that in a whole circle, we know that a whole circle is 2 pi. So half of a circle is pi, 0 to pi, right? Half of a circle is 180 degrees. So you can just change the pi to 180 and divide it by 6 and you can get the answer as 30. Or just follow the formula. Multiply by 180 over pi. The pi and pi will always cancel and 180 divided by 6 is equal to 30. Let's use a formula to do the second one. So 7 pi over 3 times 180 divided by pi. So what happens here? Pi and pi will get cancelled. 3 will divide 180 60 times. 3 times 6 is 18 with a 0. And then we have a 7 here and a 60 here. So 7 times 6, 42 with a 0 at the end, 420 degrees. So that is the answer for question number 2. Next, how can we convert to radians? So if the angle is given in degrees, how can we change it to radians? So what we do here is we multiply by pi over 180. Because when you have to convert to degrees, we multiply by 180 over pi. We just flip this fraction to convert to radians. Instead of 180 over pi, we multiply by pi over 180. So let's do that. 135 degrees times pi over 180 degrees. Okay, this sign top over here, that's the degree of it. So what happens here? The degree and the degree will cancel. So degrees are gone. We only left with radians here. And all we have to do is simplify the fraction 135 over 180 pi. And we have to simplify this fraction. So when we simplify, we see that they both get cancelled by 45. There are 3 45s in 135 and 4 45s in 180. So our answer to this question, when you convert 135 degrees to radians, we get 3 over 4 pi as our answer. One more example, 140 degrees convert to radians. Take a minute and do that. Pause the video for a second and try to do it. So let me explain it now. 140 degrees you multiply by pi over 180 degrees. What happens here? The pi and pi will get cancelled, and we get 140 over 180 pi. And what we have to do is reduce the fraction. So we know the 0 and 0 cancels, and 2 goes into 14 7 times, and 2 goes into 18 9 times. So our final answer here becomes 7 pi over 9. That's our answer.